An object starts from rest with a potential energy of 600 joules and free falls towards the ground. After it has fallen to a height of 1/4 of its original height, its potential energy is... So, we're going to use our formula for potential energy to help us solve the problem. The initial potential energy, we take the mass of the object times the acceleration of gravity, 9.8 meters per second squared, times the height. Now, we don't know what the mass of the object is, we don't know what the height is, we do know the acceleration of gravity is 9.8. Even though we don't know what the values are, we do know that when we multiply all three of those together, we get a value of 600 joules, just like it says in the problem. Now, our final potential energy, the mass is still the same mass. The acceleration of gravity is still 9.81 meters per second squared, but now our height is 1/4 the original height. So I'm going to rewrite that as 1/4 h. Now, because it doesn't matter the order that I multiply things, 1 times 2 times 3 is the same as 3 times 2 times 1. So I'm going to take the 1/4 and put that out in the front, and then I'm multiplying by mass times gravity times height. We already know that mass times gravity times height is equal to 600 joules. So now I have 1/4 times 600 joules, and 1/4 times 600 joules is 1,500 joules, 150 joules. So our correct answer is letter A, 150 joules.